Okay, so we're off into 7-7. 7-7 has a whole new kind of numbers being introduced to your life today. So welcome to an introduction. For a long time, you've been learning about types of numbers. Can anybody name me a type of numbers you've learned about? Integers. Were a type of numbers. Who else did we have? Real numbers, irrational, counting, rational, all of those. Whole numbers. When we learned real numbers, the definition at the time was all the numbers that you know. And usually I would interject, it's all the numbers you know until Algebra 2, Chapter 7. Okay, and we're in Algebra 2, Chapter 7 now. So you're about to get introduced to a whole new type of numbers. To some degree, your math teachers fib to you every time, and sometimes they just tell you, you can't do that. A lot of times what that means is you can't do that yet with the math that you know. So once upon a time, you were in like first grade or something, and your teacher would tell you 7 minus 4 is, of course, 3. And if you would ask, teacher, what is 4 minus 7? Your teacher would probably tell you, you can't do that. Okay? And what they meant is, you can't do that yet, because they just didn't, in first grade, feel like getting into negative numbers. Eventually, some teacher, I don't know, 3rd grade, 4th grade, some later grade than 1st grade, broke the news to you. Well, guess what, guys? You can do that. This is a doable problem. It's -3. And you had to wrap your little brain, whatever grade you were in, around the fact that, like, you had been semi-deceived, and there was this kind of numbers that you never, like, knew of, and it, like, was a thing now. At some point, somebody introduced you to pi, and pi probably blew your mind because that was the first irrational number you ever encountered, and it was really crazy because it's never gonna end, and it also never repeats. And at first, your teacher probably had a student argue with them, like, no, it has to repeat, you know, 3.1415927. Look, it repeated, it had a 1, and then it had another 1. And your teacher was like, sorry to tell you, but this 1 was followed by 4, and that 1's followed by 5. That didn't really repeat. There's going to be like semi-repeats, but not really. So here's how this comes to be. If I tell you that x squared equals -1, and you have to get an answer for x, how would you solve that equation? You would do the square root of -1, which until this moment in time, everybody, including me, has told you, you just don't have an answer for that. You can't do it. And usually sometimes I'd say you can't do that yet, stay tuned, or whatever I'd say. So this just has to have an answer. So what somebody did is they invented a symbol to be the answer to this question. The square root of -1 is I. Whew. It is. That's just a fact. Just trust me. These are called imaginary numbers. If you square root negatives from now on, they are doable. It's going to have something to do with this number, I. Okay, so I'm going to read to you briefly from page 324. Page 324 kind of says some of the things that I said to you already. It's a history story, but it says, when early mathematicians began to study equations, they found that an equation of the form ax plus b equals 0 could not be solved with positive rational numbers. Like, I don't know if I'm on view when I get back over here, but if I say qx plus 3 equals 0, you're comfortable with that. You just say that 2x would equal -3, so x equals -3 over 2. That's not news to you. You guys were like, it's fine, no issue. But the early math people did not like negatives, the Greek folks. They were not happy. It said Greek mathematicians who were more interested in geometry than algebra believed that an equation such as that has no solution. They rejected the idea of negative numbers because negative numbers can't be represented by drawings. Well, really they could. I mean, you could just draw yourself underground, headed down, I suppose. But later mathematicians saw that negative numbers could stand for practical ideas, such as temperatures below 0, and so negative whole numbers and negative fractions were allowed into math as acceptable members of the number family. Eventually, even irrational numbers were accepted, things like pi's, because you can draw a picture of a number such as the square root of 2, and they tell you how. If early mathematicians were uncomfortable with even the idea of basic negative numbers like -1, they were even more upset with a concept like the square root of -1. Although people knew that an equation like x squared plus 1 equals 0 couldn't be solved without inventing a new type of number, many mathematicians preferred to say something like that had no solution, or it was absurd. Solutions of equations like that were called meaningless, or impossible, or imaginary. But yet an imaginary number is a precise mathematical idea. Like any numbers, I is a symbol that represents an abstract concept, an idea. Like pi. We use that symbol. It represents a math thing, 3.14159, all that stuff. I is just a symbol that represents a math thing. It's going to obey all the rules of arithmetic. It has a bunch of uses in solving equations. It's eventually been justified. It's been admitted into math with the more real numbers that you're used to. So, open the door to a whole new world. So if we want to do this a little bit of a long way, we can break this square root into two chunks. Okay, -5 is 5 times -1. The square root of -1, we just learned, is going to from now on be called I. And the square root of 5 just is the square root of 5. We can't beat that. If I wanted to do this a slightly long way, this would be 16 times the -1. Square root of -1's new name is I. Square root of 16 is, was, and has been 4. If you do a couple of these, you realize, basically, all this negative is ever going to contribute to your life is an I. And then do the problem as you have been. So square root of 5, it just is what it is. Throw an I on there. Square root of 16 is 4. Just throw an I on there. Why did I throw the I in front of the root? So we're multiplying them. We had this conversation before. Why are we better to throw that stuff in front than behind?
So you don't mix it up like it's with the 5?
So, yeah, we don't mix up then whether it's under or over. If I put my I right there, is that in or out?
Looks like in.
Looks like in maybe. But if I go there,
Out.
it's out. Okay, so if you have roots involved, throw the I's in front just like we've thrown the numbers in front. If you have whole numbers, they're usually thrown afterwards just like we had that happen before. So square root of 18, just tune the negative out for a second. Do with square root of 18 what we've been doing with square root of 18. Yes, people are mumbling, but it's hard to hear because of this air purifier that I'll turn off. 3 root 2. Is anybody bothered with the 3 root 2-ness of that? Okay. Then because of the negative, you just pitch on there. Square root of 4? 2. Pitch on an I as well as the negative. You aren't going to do a minus minus makes plus because the radical sign interferes with that game. Don't do that. Okay, so radical negative makes I's. Root 4 is 2, and if there's a negative in front, just leave it there. Welcome to a new world. Not a hard world, just a new world. Question about what's going on with those imaginaries? Then here's the small name game. This is not like a major deal. But imaginary numbers are slightly different than a thing called complex numbers. So here's the rule on that. Imaginary numbers have the form somebody times I, where that somebody is a real number. And again, real numbers mean all the numbers you know. These are all imaginary numbers because they have the imaginary part multiplying numbers. If imaginary stuff's multiplying numbers, the technical name for that is an imaginary number. Complex numbers are a little bit bigger. They have the form something plus something I, where the other somethings are real numbers. So something like this. This would be imaginary or complex? Complex, because there's like some adding of I's and non-I's. How about this piece? That's imaginary. This piece? Imaginary. This piece?
Complex.
Complex. This piece alone?
Imaginary.
Imaginary. That is a bundle?
Complex.
Complex. This is a standalone?
Imaginary.
Real. Okay, so if you have a real adding an imaginary, that makes it complex. Is that super important? Probably not. It's just a name game. Question there? Okay, adding, you could have done adding 2 years ago. Okay, even if you didn't know what these i's meant, that they meant the square roots of negative ones, you could have done all these problems, because all we have to do is combine like terms. So 4i and 7i, 11i. The only way this is new is that you know that that I actually means something beyond just an I. Combine like terms on those?
806 plus 2.
Maybe my messiness there is messing people up.
All those together.
What plus what?
3 plus 6i.
3 plus 6i.
I thought it.
I didn't have space to write the problem horizontally, but we're going to combine the real numbers, combine the I numbers, put it all together.
I was for a second too. It's
Something about that.
I thought that was supposed to be a not a plus. That was an equal sign. I was just like really.
Yeah, no, I was trying to do this plus this. I just didn't think I could fit that there.
Yeah.
So I had to like branch. Because our countdown, which we like very much, was in our way.
Big time, big time.
We like our countdown.
Got 70 days left?
Subtracting. You could have done this subtracting problem years ago, pre-algebra kind of stuff. Because again, you're just going to combine like terms, but remember, what does this have to do? Change some signs. So the 5 is going to take on the minus, while this 7 really is plus, and then put the pieces together.
Negative 3 plus 10i.
Negative 3 plus 10i is correct. Question about that? Multiply, you could have done some of these to a degree, but you couldn't have finished them until today. This one we could have done years ago. 7i times 3.
21i?
Is 21i. This one we could have partially done until today.
18i squared.
18i squared is a start, and then I'm going to just write a super important fact here. And highlight it with lots of punctuation.
We need to know this.
If I is the square root of negative 1, what would I squared be?
Negative 1.
Negative 1. So if you ever encounter in a problem an I squared, we replace it back with a negative 1, and that's a better answer.
Negative 18.
This is negative 18. Question about that? We learned when we multiplied and had roots that you could either do the roots first or multiply first. It didn't matter that other day. It matters today. If there's imaginariness to these, you have to deal with the imaginary first, because if you just multiplied these right now, it would turn into the root of positive 36, which would seemingly be 6, but that's wrong, because you would have lost all sight that there was ever imaginariness to that. Okay, so the imaginariness of it takes priority over anything else. Square root of negative 4 is like where we came in. Make a trade on that.
2i.
2i. Square root of negative 9 is like where we came in. 3i. Temporary answer you would have thought was right until today. 6i squared. But using the full knowledge of today, it's negative 6.
It's like
Question about this corner world of stuff. So that there's really two ideas to this. I squared makes negative 1 is super important because I is the square root of negative 1 is super important. But the adding, subtracting, multiplying, other than those ideas, it's like basically the math you've been doing for years. Just combine like terms, multiply stuff, all that. Question there? Stroll to the left. I squared, we just had the whole conversation about if we're doing some powers makes negative 1. Anybody have a thought on the simplest way you could express what I to the third is?
What?
It is not. It's not.
-1.
It is not.
-1 root 1?
It is negative I. Because I cubed means I times I times I. I think we could agree on that. What is the first I times I part?
I squared.
I squared. And what is I squared?
-1.
Negative 1. Negative 1 times the third I
-5.
is negative I. That's the simplest way to express that. How about I to the fourth?
Is it 1?
It is 1. Because if you go I times I times I times I, these i's make
-1.
negative 1. Those i's make
-1.
negative 1. Two negative 1s multiplied
What?
is positive 1. If you work in a fifth I,
Negative
Just
negative
I.
I.
it would be an I.
Yep.
Just
Because
positive I.
this was I to the fourth, multiply in another I, and we'd have I. Multiply another I in,
Negative I.
negative 1. Because what we already had times another I, first thought would be I
I squared.
squared. I squared is negative 1. If we multiply in another I to where we already sat,
Negative I.
we'd be back to negative I like we were up here. If we multiply in an eighth I,
Let's just hope it's in 1.
it's all going to go back to positive 1. And at some point you realize it's just going to keep
Repeating.
like cycling through. There are going to be negative 1s, negative i's, 1s, and i's. Negative 1, negative i's, 1s, and i's. It's just going to go forever and ever and ever. Can anybody figure out where the pattern would take us by the time we got to I to the 25th? Which of those answers would we be like back to?
I'm gonna take a guess it's 5. -1.
It's not negative 1.
Positive 1.
It's not positive. It is just I, maybe because we're smarter, maybe because we just ran out of choices. Can anybody figure out how you could figure out like
The 5. I
where
to
we
the fifth.
would fall?
It's just I 5 times, and since it repeats every 4, it's just 5 times.
Okay, it repeats every 4 is super important. So there's something we can do with 4,
Wow.
and that'll give away where we are.
Divide by 4.
Divide who by 4?
The power.
Power. If we take 4 into the power, 4 into 25 goes
6.
6 times. All that means is we've gone through the cycle 6 times, but it does that division with a
Remainder of 1.
remainder of 1, which means we're back to like I to the first. In other words, I. 4 into 34 goes 8 rotations. Doesn't matter that it went 8 rotations, but it matters that the remainder is 2. So it twins with I to the 2,
-1.
which is negative 1.
Okay.
If we go 4 into this,
10.
it goes 10 times exactly with the remainder of 0, which means we've run like the full gamut. Which other ones did 4 divide into? 4, 8, so it's going to twin with those guys. It's just back to 1. If you want a way to remember that, I guess you could treat this like I to the 0, and anything to the 0, including I, is 1. So if I want to go crazy and go I to like 1,001st power, I'll do 1,003rd power, just take 4 into this. We don't care how many times it goes in, we're just hunting the remainder. What would the remainder be?
3.
3. So it twins up with what we already knew I to the third to be, it's negative I. Every power of I has to turn out to be this, 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 or this, and the remainder tells you which one if you divide by 4. That's the least important thing we'll do today. Okay, I don't think that makes the test, unless it's extra credit. Like, I think that might be the extra credit question on the next quiz. But that's the least important of what we do. To add these is going to be important, to subtract them is important, to multiply is important, but that's good news because it's just like doing math you've done a couple years in a row. The only new idea is I squared makes negative 1 is important. and the ability to manipulate these basic roots to just do the roots the way you have, just sprinkle some i's in your answer. That's important too. You're going to see i's the rest of chapter 7. You're going to see i's on and off in chapter 8. You'll see i's on and off like the rest of your math life. It's not like they're going to be in every chapter every day, but they're going to like pop out. You know, the fact that root 50 makes 5 root 2, that's like a skill you're going to do. The fact that 8/10 can reduce to 4/5. Do you reduce fractions every day? No. But once you learned it, people just think you should do that from now on. These i's, they're going to sprinkle out here or there, but not every day.
I hear that.
Sure. Question about what's up with any of this new material about imaginary numbers? Welcome to a new world. Seemed like the people that had these before that were in the room with us were fans, so I guess you could take that as encouraging news. They didn't see this and go, oh, gross. They were like, oh, I remember this, that wasn't bad. So they got positive reviews. Let's go 319. Let's go 319 and go questions on things first, because we already had some folks voicing, I got some questions on this. So let's do,
Did you say what the homework was?
the homework is 323. It goes straight through to 45, skip a few, and goes 48 to 54. That's a lot of problems. That probably means it's good news, because they're probably easier problems.
I gotta do it.
323, there it is. 319, you had something?
Okay.
Start with, what's your earliest number made you mad?
It was 26.
26.
I got 3, but when I checked it, maybe I just don't know how to check the problem. I didn't get an answer.
Okay, so it does work. So
Is
let's.
it 3?
It is 3 is right, yeah. So
Then I can't check it.
when you check it, on the right side you get a root 12,
Yeah, that's what I got.
which is 2 root 3. And then that makes sense?
Yeah.
Okay, what's your next one?
There's 32 and 34.
Okay.
I got to like an equation at the bottom, but then I couldn't like factor it, and I was
Look out.
confused.
Eraser explosion. To watch that on video later. Everybody missed a good eraser exploding off the board moment. Let's go ahead and do 32, because that's one of the ones that I think is going to bother a lot of people. So we have 1 root to begin with. We've got another root at the end. 2 roots shouldn't make you happy, okay? But if you have to have 2 roots, is this kind or unkind of a setup? Why is it kind?
Because they're on separate sides.
There's 1 on each side. So if we have 2 roots, we do want 1 on each side, so that's kind. So then you square. Left side,
4x minus 3.
4x. Well, I copied it wrong. So 4x minus 3 is true. Then we had issues over here yesterday. Sometimes people were yelling 2 things, sometimes people were yelling 3 things. What's the correct amount of things? 3 off of this. Because this is being squared. So the 2 squared is 4. When the root squares, 2x minus 5, but then we also have some foiling to do that leaves a root alive. 4 of that root. You okay with that?
I still have that.
Okay.
45, and then
Maybe I can't combine.
Anybody not okay with how that just happened to get 32 started? Even if you didn't do 32, steal it, or come back later to the video and steal it. Something there? Then if there's 1 root, what's our process when we have 1 square root in a problem?
Yeah, I see it.
Try to get it alone. So the 4 and the root, I'm going to just leave for a minute. If we get the 2x out of there, the x count is 2x. If we add the 5 out of there, subtract the 4 out of there, have a number already out of there, what's that number total going to give us? A minus 2.
I still have that. I went wrong with somewhere from here to the end.
Anybody bothered there? Now I'm going to take a slightly different tack than what I did yesterday. Yesterday what I did all the time is divide by this number. I don't really want to do that here, because if I divide by this number, I'm going to make a bunch of fractions. I would rather not make a bunch of fractions and then have to square. I'd rather just square. If I just square, 4 becomes 16, and the root becomes 2x minus 5.
I took a 2 out of the whole equation.
If I square this thing, I'm gonna get how many items?
3.
3. I'd get
4x
4x squared
minus
8x.
8x
plus 4.
plus 4. You could have taken a 2 out. If you took a 2 out of this,
I took a 2 out of both sides.
then that's fine. Your 2, did you divide the 2 into the 4 to make a 2, or did you just leave the 2 there and square it?
So I took the 2 out of both sides, so it ended up being like x minus.
So you had x minus 1 squared,
And then 2.
and then a 2 became 4?
Yeah.
That's fine.
Yeah.
Then there's
So
just
it's-
gonna make a mistake moving forward, but your steps are gonna be different than my steps, so I'm just gonna
I'm trying
bail.
to follow that now.
Yeah, I'll just let anybody who wants to finish it from there, but if what you had though is, you could work it from yours. Yours is simpler than mine, because you got 1, 2, 1, 4. Your numbers are littler than mine, it's fine to finish from there. You're gonna try to get everything on a side so it equals 0 and then factor. That's where this is all gonna go. Anybody else 319 based, anything? You're gonna get 2 answers, they both are keepers, they're both odd numbers under 10. Anybody else 319 stuff you ran into that you were like, whoa?
What do you do, 28?
28. So 28, we have 1 root on each side now, so I would just hit up the squaring process.
Oh wait, wrong number.
Wrong number?
31.
31. 31's gonna be a lot like what we just did on 32, where if you square the left side of the equals, you're gonna get 3 things. You'd get a 9 plus 6 of that root plus a z minus 6 that's no longer rooted. Do you follow that?
Yeah.
Is that new?
Kind of, yeah.
Okay. Then on the right, you'd get a z plus 9 that's no longer rooted.
Alright.
So you spot a mistake there,
Yeah.
then try to work from that. Do you understand how I got you to where we are now? Anybody else have something that is stuck that you want me to unstick it?
19.
19. So 19. Did you do anything to start it, or you just looked at it and thought, I don't like this?
I am lost.
Okay, so there's 2 ways you could start 19. One would be to put the 8 in your mind on top of a 1.
Okay.
And when you have something where fraction equals fraction, an old skill we've done on those, do you have a memory of
Like
cross multiply? So you could cross multiply, so you'd get 8 root x equals 1, and the fractions are gone,
Yeah.
and then you could square everything on that.
Okay.
Does that make you comfortable again?
Yeah.
What's the answer for 34? Because I got a fraction.
It is a fraction.
Is it 15 over 4?
It is 15 over 4.
I was so scared, and I couldn't even like check it because my calculator wouldn't do it.
Yeah, it's tough to check roots of fractions.
Shows you.
That's a win.
On that 32, the first part, how would you get the 2x minus 5 and minus 3?
Okay, so the root made us square to erase the root on the left. This, to be squared, we'd have to do 2 times itself is that, root times itself is that. But as we FOILed it out, we'd get a 2 times a root, we'd get twins of that. So there's 4 times that root total, because if we FOILed it, there'd be, can you visualize the,
Yeah, it'd be like the 2 like on 5.
yeah, there's like 2 of those. Is that an almost hand?
Oh, no,
You're just in that posture that looks like an almost hand. So be careful what posture you get in when teachers are looking at you. Call on that one. Anybody else 319, something that you started to do and you're like, uh-oh, I'm stuck? Anything to help? Let's hit up some answers if we can do it. We'll roll some time out on that. So Let's do some evens just because you have the odds in the back if you cared. 2, anybody in the 30s?
33.
It is 33. 4 is above 10. It is 11. 8 is 70s. 78. 10's another one, let's see, 10's in the 80s.
84.
It is 84. 14 is different than its predecessors. It's negative for the first time. It is negative 64. 16's the biggest answer so far. 117. 20's a fraction. 1/9. 22's a fraction and negative. It is negative 5/3. 26 is a single digit whole number. It is 3. 28's a negative single digit whole number.
-1.
It is negative 1. 32, I said, is a pair of odds, and I don't think we hit the jackpot on that. Anybody get the whole way through to have a pair of odds?
7 and 2.
It is 7 and 3, and we already verified 34 was 15/4, or if you like decimals, 3.75 would work too. Anybody that just got surprised with bad news and you want me to do something else? Anything to do off the 319? Okay. If those are good and done and you tried them all, send them down. If you're still working some of those ones at the end, work those ones at the end that you had to square both sides and they were like of about that size at the end of that. And we'll get that another time. 323 is the new thing, and that's all I got.
I'm going, Joe. I'm going, Joe.
You actually doing the homework?
I'm almost done.
Good job, Hayden.